Hello students, time for video 15b. So we're going to start out with an example that Mr. Otten brought to us, and so it is the part that we just looked at actually when we were looking at welding symbols, and we'll think about how would we fixture that and some of the considerations for weld fixtures that need to be done to make them like industry uses. So here we go. All right. So again, here's that part. Remember that we are putting a 3/32 leg length weld on the outside of this, so we need to be able to access the front of the box and all four edges from the outside. We don't need to be able to get to the inside because this weld callout says that everything is done on the side that the arrow points to, and so that's the outside of the box. Other things that would be important to us are to know that it is MIG welding. So MIG welding puts a reasonable amount of heat into the weld. It also would tell us something about the size of the weld tip that is on the robot that is doing this. We can also look at it and see that in the unfolded state, this box is about 15 inches by 13 inches. In the folded state, we don't have all of the dimensions here, but we can sort of estimate that it's about 10 inches tall and maybe 8 inches, 7 or 8 inches wide. Okay, so let's see how Mr. Otten solved this problem when he needed to build a fixture. Now, a couple of things. One is that this is a control can, and it goes on a lot of their different ovens, and so pizza ovens, and so they needed to be able to build a lot of them. So for the fixture design, he wanted to be able to produce quite a number of these, and then needed to have access for the robot. This is a visible item, so sometimes you would heat sink something like this, though he did not in this case. And the reason that you have to heat sink sometimes is just to draw the heat out of the weld. Otherwise, the stainless steel discolors in those areas, but that does not happen on this part, or I mean, it doesn't draw it out. Okay, so this is a little bit confusing. One last thing here is that to notice on the box that these little tabs that stick out to the side are near the front flange, and so that will help us to see things a little bit better. All right, when Ben does his modeling, he actually does his modeling in Mastercam because he does all of his path planning in Mastercam. And Mastercam is not the most powerful modeler. It does just fine, but if you get really big assemblies, it starts to choke pretty well. So there's a lot of detail that is kind of left out of his initial fixture drawing, but it has all the things that he needs to figure out what's going on. So the green shapes here, there are 6 green shapes. Those are the boxes, and remember that tab that I said that was near the front side. You can see that the tab is right here, so the front in this drawing is sort of the top right to get to these. The boxes are mounted vertically in this fixture, and the pink and red piece right here and then the pink and red piece right here are on slides with pistons, and so they can move down and to the left to open up to be able to install the box, and then they move up and to the right to clamp the box in place. Now, because it's sheet metal, we're not going for determinism on a box like this because the sheet metal is floppier than that, and if we only held it in 3 places, we would end up denting 3 places, and then the rest of the sheet metal would not necessarily be in the right location. So we're going to over constrain these parts by quite a bit. We need to understand ahead of time whether the parts will be oversprung or undersprung, meaning do we have to push on the sides to close it up a little more to be ready to weld it, or do we have to pull the sides open to get them to the right position? Now, you could have it where you're aiming for it being exactly the right size, or exactly bent the right amount. Sometimes that makes it harder because then in the fixture you have to be able to control both something that got overbent and underbent. And so these parts, we can tell by the way the fixture is put together that these parts are going to come to the fixture underbent, not bent enough, and so each of these side panels will be sprung sticking out just a little bit to the sides of the part, and so when the operator puts them into the fixture, they're going to be sort of squeezing it into the fixture, and that squeezing action will hold the parts in place. So the front is over here to the upper right on each of these parts, and so that is the side that will be sprung open more. And so you can see that there are big bars here. The big blue bars are being used so that when you put the part into the fixture to get it to fit between these blue bars, sort of squeezes the sides into place. And then when this sliding red and pink structure comes into place, it will position the back end to make sure that the whole box is not askew to the left, right, top, or bottom. Other things you can notice on this fixture is that these bars that are positioning it leave the corners open, so it's easy for the welder, the welding robot, to get in here to the corner and then to get down the front face. It's a little harder to tell that. Now, how does it get to the welds that are on the bottom side of these boxes? Well, this is on a rotating table, and so when the welder is working on it, it will weld the tops of all of these and then rotate the table and weld the bottom. So let's look at the real fixture a little bit and see how this is done. So this all rotates for the next picture, which is unfortunate, but here we go. So this is the fixed side. This is that pink and red side that was moving back and forth. This is fixed and this one is moving. So the box fits between this rail. These were like the light blue rails in the last picture. So there was a light blue rail there, one there, one there. So you take the box and you push it in. The front of the fixture is over here on the left side in this image. And then this slide comes in on the back and positions the fixture, or the back side of the box. And a couple of things to note is that as this is sliding in from the back, there's a little bit of a chamfer here, it looks like, or a little bit of at least a wear surface, so that as it comes in, it can position that box a little bit more accurately where it's going. So yeah, that's something that is a little hard to tell here, but down here on the bottom of the fixture, instead of having just a little tab, it is a really big bar that is positioning the part, and that keeps you from accidentally pushing the part too far down through the fixture when you're putting it in place. And so that's just a way to make it easier to install things in the fixture. Let's look at some of the other designs of this fixture. One thing that you notice is that this fixture is using extruded aluminum. There are two brands of this extruded aluminum. One of them is Bosch Rexroth, and the other one is a company called 8020, 80-20. Ben uses Bosch Rexroth because he's found the dimensionality to be a little bit more consistent on Bosch material, even though it costs a little bit more. And then that allows him to build up the structure relatively easily. You can just join it together with these screws. You're not custom making any of these parts. You just buy this structure and cut it to length. And then he machines a lot of these special parts that go in the center, but you can see that they're all relatively simple parts. They tend to be very blocky, and try to make things as easy as you can. Make it so it takes only one setup or maybe two setups to make each part, if at all possible. When we look at the pneumatic system, so these pistons that are opening and closing the right side are pneumatic. He doesn't always use pneumatics. A lot of the time he will use manual closing clamps whenever he can, just because the cost is lower. But you can see that he has two colors of airline in here. And I ask him if he tries to always, well, he has three colors of airline. I guess there's yellow also. I ask him if he tries to keep it so that all of his fixtures have one color for the pressure side and one color for the release side, and differences between low and high pressure. And he said no, that it just hasn't worked out. They often have to just go with whatever tubing is available, and so they don't try to do that, though that would make it easier to troubleshoot the fixture. You can see that a lot of his ways of joining things are these push um, components, where you just push the tubing into the end of the component, so there isn't any real hard work in building the pneumatic system. It's really quick. And then one thing that is really important, he said one of the most important things at all, is these 4 items right here. So what these are is they're called speed controls, and they have a little needle valve. You can see the little end of the needle valve right here, and they adjust how fast the air can flow through here. Now it's going to be sort of the same pressure on both sides, but they adjust the speed that the air can flow through. And what that does is it allows him, for every piston, both on opening and closing, it allows him to control how quickly the piston opens and how quickly it closes. That prevents a piston from slamming against the end of its motion path all the time, but it also allows you to sequence things, because if you make one set of pistons operate more slowly than another, then you can sort of do you know, an A and a B and a C datum. So if you want to position something one place first, and you know, against a flat first, and then push it to the side, you can do that just by adjusting the speed that those pistons are closing. And this makes it so you don't have to program PLCs and use servos and a lot of other things that would be a lot more expensive and complicated than makes sense in this case. All right. One thing that I mentioned in the previous class was that you have to be really careful about all these plastic lines and all these components from weld spatter. And so when this fixture actually is used, it looks like this. And there are cover plates that go in place over all of those lines to help keep the weld spatter and also the ultraviolet radiation from hitting the parts, and from hitting all those lines. And here is the here it is in service. So you can see this orange thing on the end. That is the table that rotates. You can see the robot coming in here, and it's welding along the edge, and then it can weld down the front face right there. You can see that this one's already been welded. It's got some discoloration to it. And so it would weld on this side and then flip over and do the other side. And in fact, here's what the other side looks like. Remember, the block that positioned it was a much bigger block to help keep from accidentally pushing the control box too far through when getting it in place. And you can see that these have all been welded, and they leave a big amount of space so the robot programmer can easily get the big nozzle of the robot in there to do some welding and not have to worry about running into things. Okay, so in the next videos, we're going to look at some specific components that are used and drill down a little bit deeper in the practices that Mr. Otten uses. All right, looking forward to it. See you then.